Hi there, I'm how you of me solving a numerical problem. So let's begin. Today we need to find the lowest common ancestor in a binary tree. So we are given the root of the binary tree, right? The lowest common ancestor is the common parent, right? And a node can be a descendant of itself, right? So for example, if we're looking for find one, right? Find one, the lowest common ancestor, which is three, right? So if we look for let's say 5 and 4, right? 5 and 4 here, right? So the lowest common ancestor is going to be 5. So because of that, there are three ways we can find it, right? We can either found a target, right? Either P or Q at the root, on the left or on the right, right? So so if we found on the left, right? Found on the left, found the root, right? Or found the right, right? If the sum of these three, if two of them, 2 out of 3 are true, right? 2 out of 3 are true, right? Which means that we found the target, right? We found the ancestor or the lowest common ancestor, LCA, right? So if 2 of 3 are true, so which means we can go ahead and return the root, right? Right. If it is left and right, which means the pattern is the root, right? Like left and right, the pattern is the root. Right? If we found one on the left, found one on the right, so the pattern must be the root. Right? If we found the root and the right, so the pattern is still the root, right? If we found the pattern on the left, the pattern is still the root, right? So if 2 of 3 are true, right, we can just return the root. Okay, so let's look at an example here. 3, 5, 6, right? This is 2, this is 7, and this is 4. This is 1, 0, and then 8, right? And P is 5, and Q is 4. Okay, so we have to traverse out the 3. Right? We have our LCA to know here, right? So we look, we compare the parent, right? Not equal, right? So this is a 0, right? This is false. So uh, let's we can add them together, right? Because if we add a true to a true, right? This is a 2, right? Because when we add the boolean together, they're gonna championship gonna converge to an integer, right? Which is 1, 1 or 0. False is 0, true is 1. Right? So this is 0 because 3 is not the same. We can try target here. So we go left and we go right, right? If we go left, we found 5, right? So this is 1. If we go left again, we don't find anything, right? So we return 0. If we go right, we don't find anything, by 2. So we keep going, right? So this is 7. It's not target, right? So we look at here, the 4 for the target. So we return 1 here, right? We return 0 here, right? So we return 0 here, we return 1 here. And 2 itself is not the root, right? It's not the target. So if we look at this subtree, only 1 out of 3 are true, right? Which is the same as only 1. So we just skip that, right? Okay. So what do we return back up to the next subtree? We're gonna return 1, right? So we ask ourselves, okay, the root is 1 because the root is p. So do we found anything on the left? No. So do we found anything on the right? Yes, we do. We found something on the right, right? Which is 1 here. Right. If we found something, we're gonna like return either uh left, right, or right, or root, right? So we're gonna return 1 here. So because we found something on the left, on the right, sorry. we found something on the root, so we can set our LCA the root to be 5, right? Right. So similarly, what do we want to return back to 3 here? So 3 is not the target, right? So it is a 0, a false. But if we find something on the left, so yes, we found something on the left, right? So we're gonna re return 1 because we found something on the left side. Okay. And here, I'm just not gonna going over it, but we're gonna return back up 0, right? Because we don't found anything on the right. So it doesn't matter how many target that we found in a subtree, right? As long as we found something, we only return 1. Return 1. Right. So the sum is only 1, so it's our LCA gonna be the same, right? Right. Yeah. So when we found something, we're gonna just return 1 or just return true, right? We don't want to return the total number of what we found because we don't want to add up, right? We only want to know that if we found something on the left and we found something on the right, or we found something on the root, right? Then it means that the root gonna be the common ancestor, the lowest common ancestor. Okay, so let's code this up. So we're gonna have our LCA type of function here, taking the root. Okay, so a file in the root, so equal to root of val equal to p, or root of val is equal to q, right? File in left, then the LCA of root of left, right? Sorry, all that left, and file in right means in right equal to all that right, right? And then if file in root, right? File in root plus file in left plus file in right, right? Greater than 1, greater than 1, right? We can set the root, right? The common, the other ancestor to the root, right? To R. And so we can have our common ancestor here, diagonal, or we can return it at the end, return the ancestor. We need to call the LCA passing in the root. Okay. So if we found something on the left, in the right, if it is the two out of 3 are true, right? The sum is at least 2. We're gonna set the ancestor, and then we want to return it, right? We don't want to return the sum. We only want to return true or false, right? Or 1 or 0. If we found something or not, right? If we found something, we're gonna return 1. Otherwise, we're gonna return 0. Right? If we don't have a root at all, right, we're just gonna return 0. Doesn't matter. Okay. Um. So again, we compare the root, right, to the target. That is not equal, so we just look in the left side and on the right side. If we found something on the left side, if the target is on the left side, or the target is on the right side, right? If two of these three are true, which is the sum will be at least 2, right? We're gonna set our ancestor to R. Otherwise, we just return if we found something or not. Okay. No. Let's see what's wrong here. So our root equal to order val, right? Passing in the root here. equal to P. Okay, is P a value or a node? P is a value, right? No, P is a pre-node, right? So we need to actually do q.val and then p.val. Let's try it again. Oh, and now it worked. Submit, and thank you for watching.